Hi, my name is Isabel Stead. Today I will be presenting the geography of the United States and Arizona. Here's my presentation slide. Today we're covering the topics of what is physical geography, physical features of geography, and how physical areas are defined. The Arizona Social Studies standards that we are including within this slideshow as well are HSSP12, which is analyze change and continuity in historical eras. HSSP 2.1 is to analyze how contexts shaped and continue to shape people's perspectives. And then HSSP 4.1 analyze multiple and complex causes and effects of events in the past and present. Here we go. All right, what is physical geography? The geography type that analyzes and researches Earth's natural features and how they form and change over time. That's just what that is essentially. Geographers study the natural forces in different parts of Earth to understand how they affect the world around us and make the landmarks we see today. For example, my best explanation of what a physical geography is going to be like thinking about different map types. When you see different elevational map types, scientists like to study the elevation because that's one of the features of physical geography. You'll see that type of map has the little rings on it. I'm forgetting what they're called, with different numbers marking the height above sea level or below sea level that they lie. And if you look at a mountain range, you'll see a ton of circles with higher increasing numbers for the steeper the mountain as they go, and the closer that they are together basically explains the steepness without even showing you the numbers. Physical geographers may have master skills within climatology, hydrology, glaciology, and biogeography. So basically what climatology is it's the study of Earth climate and weather. Usually the people you see on the news who are reporting the weather and the forecast for the week, those are meteorologists, and meteorologists have the main job of reporting weather, and that's climate. So that's one of the job types of what one of those people would do. Hydrology is the study of all forms of water. If I were to be working on, let's say, a bridge and the hydraulics of it, for like a dam, or like the people that build the dams, that's the kind of geography that those scientists and engineers would be studying. Glaciology, the study of ice and glaciers. I'm not gonna lie, I have not fully researched into this job type and what these people study, but I would assume these are the type of people who would like to go down to Antarctica and study the different ice formations and how they were made and how they are currently keeping what their current behavior is, whether they're staying together in their formation or they are melting, as we know. And then biogeography is the study of geographical spread of life forms like plants and animals. I would assume that these types of scientists study different types of animals and their migration, of how they get from one place to another and why they get there and why they build the habitats that they do amongst physical geography. For example, when you think of a mountain lion, you would think of a mountain lion, the mammal that lives within mountains and more of a drier climate rather than a forest climate. For an example, another kind of animal that you would find in the desert would be a snake, and lots of reptiles and amphibians live in the desert because of their ability to sustain to their heat. They need the heat. This information for this slide was pulled from Crash Course, What is Physical Geography? And then the rest of the information was also pulled from What Do Physical Geographers Study? An In-Depth Exploration by spatialpost.com. And then this is what the slide looks like. I don't know if it's gonna adjust. All right, why is physical geography important? Well, geography is important for many reasons. Like I stated earlier, a lot of maps rely on the physical geography of one area to be studied in order to create those maps properly and provide the correct information for anyone who might need to use that type of map. But on the slide, it states that physical geography is important because it helps and allows for preparation in future national disasters, helps us manage our sources like water, land, and minerals, allows us to understand how our daily activities may impact the natural environment, and then helps in understanding our ecosystem. All right, let me show you this one. Go. All right. Did you know? A fun fact is, without physical geography, the phenomenon behind the Grand Canyon wouldn't be able to be explained. All the different colors in the Grand Canyon, amongst the different levels, are due to natural minerals being exposed to oxygen over millions of years. Erosion from the Colorado River formed the Deep Canyon. And then the different sedimentary rock layers different sedimentary layers of rock were formed due to weathering over millions of years. Weathering is just another word for erosion. So basically what that means is, over time, when there's so much, I guess if you want to call it wear and tear to the surface of the rock within the Grand Canyon, that rock then begins to unform itself, where it'll fall off, it'll slide down, and some natural disasters that are due to erosion are going to be like landslides, mudslides, I don't know what the ice one's called, but when there's an earthquake, sometimes if there's an earthquake on like a really steep mountain hillside, a ton of rock will then begin to just fall straight down. And when that happens, again, that is called erosion. As well as another one is another example of weathering is, there is a theory that the Grand Canyon was once filled with water all the way. And the idea of that being filled with water is, as that water slowly drained out over time, more parts of the rock were exposed, and as the different parts of the rock were exposed, that's how you get those lines of the different sedimentary rock layers within the Grand Canyon. So, for instance, with glaciers too, it's the same thing. As glaciers melt, different layers of its water and their ice will shed off, and you'll see that's how that glacier will get its shape. Again, that's just another different type of weathering that we see in our everyday environment. Let's see. The sources that we used for those were the geology from the Grand Canyon National Park, U.S. National Park Services. And then we also got our other source, I'm so sorry. What are the colors of the Grand Canyon by Jeff Sosa. And then let me show you this one. Here's that slide. All right. Examples in physical geography. Physical geographers use thermatic maps which show the pattern of a specific subject in a given area. These geographers are able to study place by observing human patterns and how they interact with Earth's characteristics. This allows us to better understand spatial awareness with Earth and how humans help to shape the planet and climate. So basically what this kind of map does is, if you were to think of a thermal camera, and when you're looking through that lens and the screen that pops up to show you, it pops up in different colors from cold to warm. When looking at pollution and how humans have impacted have increased their pollution and carbon footprint, you'll see that in busier populated cities that you'll see warmer colors, as the warmer colors stand for a denser hazardous area, because the thermal camera will pick up heat, and because all of that gives off heat and radiation, that will again pop up as the red on the map. Okay. And then when looking at further away cities that aren't very populated and are very small and more off the grid, you're going to see colder colors, as they don't show enough activity. Another type of use for a thermal map would be the forecast being used in the news. When meteorologists on the news are looking to explain what the forecast is, or what kind of rainstorms are coming and how they're navigating their way down to wherever you need to go. For example, if there's a storm up in New York, and it has a pattern of following downwards in the same direction as if it were to hit Arizona, we would watch a warm color, or blob, I guess, with lighter warm colors surrounding it, drift down in that pattern, bringing along whatever kind of front that storm wants to bring directly down, and it'll carry all of its storm with it. So as you'll look across the screen as it's happening, you'll just see that bright blob of big warm color move all the way down until it got to where it ended, and then eventually it'll drift out. Another kind of thing that can help us read thermal maps and why we would read them is looking at lakes and helping us navigate depths of the lake, or depths of oceans and lakes and water formations. As if we use them, we're able to see the deeper areas versus the shallower areas, as well as elevation. Again, I mentioned that earlier, the elevation, the higher it is, the warmer the color would be, and the deeper it is, the colder the color would be, to represent below sea level versus above sea level. And then we got this information from How Do Geographers Study Place by Jenna Stark from Geographic FAQ Hub. And then we also took information from ncesc.com under the geographic facts. And I'll show you this slide. Here we go. All right, physical features in geography. The natural characteristics of Earth are considered physical features. Physical features include mountains, lakes, deserts, oceans, volcanoes, plateaus, gulfs, bays, capes. Those are just some water formation ones. What else? We have valleys, we have mesas, we have like lagoons, if we want to get into like forests and lakes. One of our examples that we have stated is the Himalayan mountain range. So the Himalayas are located in Asia as a result of tectonic plate collisions from over 50 million years ago. Below, we also have stated a question: can you think of any different physical features? Again, I did name some. However, now I'm going to explain the Himalayan mountain range. So that mountain range was basically formed by our tectonic plates. There's 3 different, I'm going to forget their names. There's 3 different movements. They can either butt heads, and usually this creates like mountain forms. So when they're going at each other, they are basically like that, and they're working up with so much tension that that's how mountains are formed. As well as we have one that we have a tectonic plate that will overlap, will go above or below, and then we'll also have tectonic plates that can pull apart. Tectonic plate movement is the theory in which we got to explain how our continents are in the places that they are. Originally, there was Pangea, or we thought to believe there was Pangea, where all of our continents were together, and all of our continents eventually broke up due to their tectonic plates movement, and slowly over time they began to drift. Henceforth, that's where they are placed now. One of them, I do remember the names. One of them's convergence, one of them's divergence, I believe. Yeah, and then we got those, that information from What Are Physical Features of Geography from the California Learning Resources Network. And then What is a Physical Feature from Graphicpedia.com. And this is the slide for this one as well. Pretty odd for spoken to you. Alright, why are physical features important? Many reasons. Physical features influence human and animal lifestyles based on adapting to your environment. For instance, my best example of why physical features would be very important to me would be in the past, people who make maps, cartographers, they have to have a great idea of what kind of land that there is to plan and to look at, and how they have to use that in order to map out for the future what roads, how to tell people what directions to take, and so and so. For example, if I was to go down to Mexico, I would have to look at Google Maps because I don't know how to get there myself. And in Google Maps, you have the ability to select a map type to look at the terrain around you, and you'll notice on those maps that there are a ton of mountain ranges, tons of hills, a lot of desert. So if you were to go in and look at that, you would be able to see exactly where that was all mapped out. All because we had the full map that was originally made by those cartographers many, many years ago. Same thing while looking at Apple or Google Maps. If you were to zoom into an ocean, you would see a big blue blob, probably with the name ocean in it of some sort, and that would be Google or Apple Maps' way of telling you that there's a big body of water there, whether it be a lake or an ocean or the beach or a river, which is very helpful because even if it's dried out, it'll still tell you that formation was there at one point, or this formation is currently still there. It could be a hazard to you, it could be where you're going, just all of the above. Another example of Google and Apple Maps using like physical features of a physical map would be looking at elevation as well. When you're looking at the coordinates on Apple Maps, it gives you the ability to see those, and then right next to it also gives you the ability to see the elevation of let's say a mountain you were hiking. If you were to pull up like Black Mountain hike, you would see the exact coordinates for whatever point they have selected, as well as the elevation of that mountain or hike you would complete as well to the very top. On our slides, we state that physical features allow us to understand how our daily lives can affect the world we live in, and can teach us how to become eco-friendly. And basically what this is saying is that with our knowledge being provided to us by these sites and all of this information, we are able to plan accordingly and navigate through. Okay, never mind. Okay, how to navigate through time effectively. Same with our environment without, again, running into hazards, destroying property, all of the above. Physical features directly impact how we act and treat the world around us. I think my best way to describe physical features and how they can directly affect neighborhood behavior is depending on the location of it. In the desert, we tend to all get a lot really, really hot in the summertime. So because we live in the desert, all of us living here, we have to react in a certain way to where we all have to get air conditioning, and we all we won't park in the sun because we'll walk into super hot cars. We all have pools, and we all go swimming in order to cool off. Again, in the summertime, we all try to avoid going outside just because of how hot it is. So that's just one behavior that we have in order to react to our physical environment of Arizona. Physical characteristics are what make human life possible, as they allow us to use and study our natural resources, creating a clearer understanding of how the environment works for house life. Physical features can form or corrode to other natural features as well. Again, back to erosion. If I were to have, let's say, just a singular mountain just standing alone, and this mountain were to experience so much erosion over time, eventually you will just see the mountain begin to decrease and flatten out, maybe to like a plateau or a mesa, or even just bevel out. Is that the word? Yeah. The sources that we use for those are how do physical features affect human development, as well as what is a physical feature. And then here's that slide. Let me fix this. Let's see. Geography fun facts. The United States is the third largest country in the world based on an area with about 3.8 million square miles. Okay. That was a little silly word jumble there. I do agree with this, even though Europe seems to have all, like that continent seems to have all that space. Technically, it's not a country, so that makes America the third largest country because I believe, let me see, I don't know if I can exit. Let me see if I can find, because I didn't write that down. What is the first largest country in the world by like geographical geographical space is Russia with 17.1 million square kilometers. Gosh, let me scroll back down to this. Another fun fact is Arizona is home to the only poisonous lizard in the U.S., the Gila monster. The Gila monster is very important to Arizona and our culture because we have tons of schools, we have tons of what are they called? Casinos, roads, areas, neighborhoods named after the Gila monster. Fun fact, if you were to go to the Westin Kierland, in their main lobby, they have some animals on display. I'm not sure how well they're kept, how well they take care of them. However, they do have a Gila monster on display, so you're able to see one. I've never had an encounter with one. However, I have seen people post about them and show their experience of finding them on their front doorstep. But you'll usually find those little monsters under rocks in shady places, especially in the summer, because they like to escape from the heat, as well as in more of a rocky, deserty area rather than being next to like a pond or a little lake. They kind of live like snakes. That's my best example of how to explain their habitat style. The Grand Canyon began to form around nearly 6 million years ago. The reason it formed was because of the Colorado River. And the Grand Canyon became a national park in 1919, and it continues to be a popular tourist attraction to this day. One of the biggest tourist example attractions of the Grand Canyon is tourists will come and they will spend several days hiking down into the canyon, hiking through it, and then hiking right back up. Horseshoe Bend happens to be one of the most populated attraction that the Grand Canyon holds. It's this natural formation within the canyon that literally looks like a horseshoe from the top looking down, and the river runs right along the bottom of it. Again, with another popular attraction the Grand Canyon has is the water rafting. I think that's what they call that, where tourists can rent tubes and raft throughout the Grand Canyon. The United States is home to the hottest place on Earth, Death Valley, California, where the hottest ever recorded temperature was 134 degrees Fahrenheit on July 10th, 1913. A lot of people like to argue that Arizona is the hottest place, and then a lot of people like to argue that Nevada is one of the hottest places that we have in the United States. And our fun fact basically will tell you neither one of them are the hottest, because Death Valley, California is. If you were to drive, I believe, to San Diego from Arizona, you would be passing through Death Valley. It's usually a really quick spot to get through, and there's no hassle. But the idea of passing through there and your car breaking down, you have a higher possibility because your car can't stand the heat on a very hot day, as well as if it were to break down, you would be stuck in one of the hottest places and it would be miserable, in my opinion. And then the websites and resources that we used for those were Britannica.com, GrandCanyonGuru.com, and science.org. Here's the slide for that. And then our discussion questions. What role did the Colorado River play in Arizona's geography? And then we have, what is an example of physical geography feature, the physical geography feature, and how does it affect the environment? How are thematic maps important to geography? And how does a physical feature affect you on a daily basis? And then here's this one. And then let me scroll down to the last page. And this is just all of our works cited amongst one slide. But other than that, thank you for listening to my presentation about geography or physical geography within Arizona. Thank you so much.